Time now to do a little algebra review, and we're going to start off by talking about order of operations. And we're going to look at some mistakes that students frequently make when working through an expression. And we're going to start off with the biggest mistake that I often see, and it's not calculating the multiplication and division before the addition and subtraction. If you remember your order of operation, multiplication and division are higher up on the list there than addition and subtraction are. So looking at this first expression here, well, I see there's subtraction here, 15 minus 7, but I also see there's multiplication, 7 times 8, and I have to do the multiplication first. So I'm going to bring down my 15, and then that's really like a negative 7 times a positive 8. A negative 7 times 8 is a negative 56. And now we're left with the subtraction here. We've got 15 minus 56. Those are different signs. And so I'm going to subtract those, and I'm going to end up with a negative 41. And it's negative because the negative number, negative 56, has the greater absolute value. Looking at example number 2, again, I've got to think order of operations, and I see an operation inside of the parentheses here. So I'll go ahead and evaluate that first. 6 minus 8 is going to be a negative 2, so I'm going to have 9 plus 2 times negative 2 raised to the third power. And now I'm going to have to evaluate that exponent. All right, negative 2 to the third power, that means negative 2 times negative 2 times negative 2. Well, negative 2 times negative 2 is 4, and 4 times negative 2 is negative 8. And so this is going to turn into 9 plus 2 times negative 8. And now when I go ahead and evaluate, again, I've got addition or multiplication. I'm going to multiply first. 2 times negative 8 is a negative 16. So this turns into 9 minus 16. And again, different signs here. I'm going to end up subtracting here, and that's going to give me a final answer of negative 7 for that expression. The second mistake that I see is treating the exponent of 2 as a multiplier of 2. When you square something, that does not mean to multiply the value by 2. It means to multiply the value by itself. So in this example, I have 4 times negative 3 to the second power. I'm going to evaluate the exponent before I multiply. Negative 3 to the second, again, that does not mean negative 3 times 2. It means negative 3 times negative 3, which is a positive 9. So this turns into 4 times 9, which is going to give us a final answer of 36. Looking at example number 4, well, again, I have an operation inside of the parentheses. I'll go ahead and evaluate that first. 6 plus 3 is 9. So we have negative 2 times 9 to the second power. 9 to the second power, 9 times 9 is 81. So I've got negative 2 times 81. And that's going to give me an answer of negative 162. Now we're going to look at evaluating expressions. When you evaluate an expression, the first thing that you need to do is substitute in the values of the variables. And I've told you for this expression, I've got 2a squared minus 3b plus 7, that a is negative 3 and b is negative 4. So the first thing I'm going to do is actually substitute those values in. This is going to turn into 2 times negative 3 to the second power. Make sure you put that negative 3 in parentheses, minus 3 times negative 4 plus 7. And now I'm going to use my order of operations. So I'm going to have to evaluate the exponent first. Negative 3 to the second power is negative 3 times negative 3, which is 9. So I have 2 times 9 minus 3 times negative 4 plus 7. So I've got some multiplication here. I've got some multiplication here, and I've got addition. I know I need to multiply first. So I'm going to have my 2 times 9, which is 18. That's a negative 3 times a negative 4, which is a positive 12 plus 7. And now I'll take care of my addition working from left to right. 18 plus 12 is 30. And then when I add the 7, I'm going to have a final answer here of 37. In the next example, we're going to be combining similar terms. And when we practiced this way back in topic number 4, we said we were going to circle our variable terms, we're going to underline our constant terms, and we're going to shuffle the problem around so that our similar terms are next to each other. So my variable terms that are the same here, I've got a 3a, a negative 6a, and a positive 2a. And then my constants that I'll underline, I have a negative 8 and a positive 12. And so I'm going to reorder this variable terms first. I'm going to have 3a minus 6a plus 2a minus 8 plus 12. And now I'll combine my similar terms. 3a minus 6a is negative 3a. And I'm just going to bring everything else down to the next line. Negative 3a plus 2a is negative 1a. And now all I have left are my constants combined. Negative 8 plus 12 is a positive 4. So I'm going to have negative 1a plus 4 Or you can just write that as negative a plus 4 if you would rather. They are equivalent expressions. Next, we're going to look at solving equations, and you must be fluent with two types of equations. There's the two-step equation, and then there's the distributive property equation. And we'll start with the two-step equation. We have 5a plus 13 equals 43, and our goal here is to isolate the variable. And so I look at my variable terms over here on the left side. I see I've got this 13 that's with the variable term. So I'm going to go ahead and subtract 13 from each side as my first step. On the left, this is going to leave me with 5a, and on the right, this is going to leave me with 30. But I don't want 5a, I want 1a, so I'm going to divide each side by 5 to make that happen. 5a divided by 5, there is my 1a. 30 divided by 5 is going to have a value of 6. I'm going to go ahead and do my check just to make sure that I've done everything correct. Remember to rewrite the original problem first. 5a plus 13 equals 43. Substitute in the value of your variable. We think a is 6, so we'll have 5 times 6 plus 13 equals 43. And now use your order of operations. We multiply the 5 times 6 first, 30, and now add 13. And when we add 30 plus 13, well, we're going to have 43, and I can see that the two sides are equal, so I know that my check has worked. In number A, this is my distributive property equation. I have 4 multiplying the 2a minus 7, and the answer is equal to 20. So I'm going to go ahead and distribute the 4 to each term inside of the parentheses first. I have a 4 times 2a, and then my 4 is positive, so I have positive 4 times my negative 7 equals 20. And when I evaluate this, I'm going to have 8a minus 28 is equal to 20. And now this is just your two-step equation. I've got to get my variable terms alone over here. There's a negative 28 with that, so I'm going to add 28 to each side. Add 28, and on the left, that leaves me with the 8a. Negative 28 plus 28 is 0. 20 plus 28 on the right side is equal to 48. And now I've got to get my 1a, so I'm going to divide each side by 8, and a is going to have a value of 6 in this example. A equals 6. When we do our check, remember, use the original equation. 4 times in parentheses 2a minus 7 equals 20. Replace the a with the 6. 2 times 6, I'll make that say, minus 7 equals 20. Inside of the parentheses, I've got my multiplication, 2 times 6 that I'm going to do first. That's going to be 12. And then in the parentheses, I still have 12 minus 7, which is going to give me 5. And so the last part of my check here, I just have to do 4 times 5, which I know is 20. So 20 equals 20. And again, this equation checks. Solving an inequality is very similar to solving an equation. Your goal, again, is to try to isolate the variable. One thing that we need to remember, though, is that our inequality symbol is going to switch anytime that we multiply or divide by a negative number. Adding, subtracting, that will always preserve the symbol. Multiplying and dividing by a positive number will preserve the symbol. But if you multiply or divide by a negative number, that's going to reverse your inequality symbol. So looking at this inequality here, well, I'm going to add 8 to each side at the beginning. This is going to be negative 2m on the left. I added, so that's going to preserve this symbol, so it's going to stay less than or equal to. And then 6 plus 8 makes 14. I don't want negative 2m, though. I want 1m. To make that happen, I'm going to have to divide each side by negative 2. Negative 2m divided by negative 2 is m. 14 divided by negative 2 is negative 7. And I just divided by a negative number, so my inequality symbol is going to have to reverse. And so my final solved inequality says m is greater than or equal to negative 7. To graph that, I'm going to start at negative 7. Since I can be equal to negative 7, I'm going to put a closed circle on negative 7. And then I need to be greater than, so I'm going to shade my number line to the right. And I'm going to bold the arrow on the right-hand side of the number line as well. And so any of these numbers that now have been shaded in would be a solution to the inequality. Looking at an inequality word problem here, I'm going to try to translate this into some words and figure out what it represents. The cost of a pizza and 4 small sodas can be represented by the inequality p plus 4s is greater than or equal to 22. which choice correctly describes the inequality? And we really need to focus on that inequality symbol right there. Well, A says the pizza and 4 sodas cost more than $22. Well, that says greater than or equal to, so it can't be that one. And B says the pizza and 4 small sodas cost less than $22, which we know can't be true since that's a greater than or equal to symbol. C says the pizza and 4 small sodas cost at most $22, and D says the pizza and 4 small sodas cost at least $22. We need to understand what these words here mean. At most $22 means $22 or less, and at least $22 means $22 or more. And since this is a greater than or equal to symbol, it's going to have to be choice D, $22 or more, at least $22. When we're trying to translate an expression into algebra, we've got to pay attention to our keywords. And one common mistake is when we see the words less than. When we see the words less than, make sure that you switch the order of the terms. For example, in A, it says 6 less than twice a number. When I create the algebra, I'm going to have to do twice the number first, which I can just write as 2n. And then if I want 6 less than that, I'm going to have to subtract the 6, 2n minus 6. In part B, it says take 5 from 3 times the number. Well, when you take a number from something else, well, again, you have to switch the order around. In this case, I'm going to do 3 times the number first, 3n. And then if I take 5 from that, I'm going to subtract the 5. In part C, it says 7 times the number is at least 40. So I'm going to have my 7n, 7 times the number. And then up above, we said the words at least means, in this case, 40 or more. And so I'm going to have a greater than or equal to symbol here. 7n is greater than or equal to 40. In part D, it says 9 plus 5 is at most 50. Again, at most up above we said was less than or equal to. So we can just write 9 plus 5 is less than or equal to 50, which is a true statement. That would say 14 is less than or equal to 50, and it is. When you have a word problem in front of you and you're trying to determine if it's an equation or an inequality, again, you've got to try and read your key words. In example 12, it says that Lawrence ordered 4 books on the internet. Each book costs the same amount. The total cost is $67.50. That sentence right there lets us know that we're going to be working with an equation because the total cost is exactly $67.50. That includes a $7.50 shipping charge, and it says to write and solve an equation to show the cost of 1 book. So what I'm going to do is write my let statement here. I'm going to say let n equal the cost per book, and then I'm going to try to create my equation. Well, reading my keywords here, I know I'm buying 4 identical books, so I'm going to have 4n. And I know the cost was $67.50, and that included a $7.50 shipping charge. So I'm going to have plus $7.50, and that equals the total of $67.50. I'm going to subtract the $7.50 from each side. Again, I'm trying to get n all by itself. This is going to give me 4n is equal to 60. And now when I divide each side by 4, I can see that n equals 15. Okay, we would go through after this. We would do a check. The check would work out. And then what this means is that each book costs $15. That's the meaning of the answer n equals 15 in this example. In the last problem, we're told that Larissa wants to buy a guitar, but she does not want to spend more than $350. And again, that sentence right there lets us know that we're working with an inequality. If she doesn't want to spend more than $350, that means she can spend less than $350 or exactly $350. We're told that she has $100 already saved, and if she saves $40 per month, then how many months will it take for her to save for her guitar? So again, I'll start with my let statement. In this case, I'll say let n equal the number of months, because that's what we're interested in finding. All right, let n equal the number of months. And then we know that she's saving $40 per month. N is my month, so I'm going to have 40 times n. She has $100 saved, so plus 100. And she doesn't want to spend more than $350, so that could be less than or equal to $350. From here, we would subtract 100 from each side. That's going to leave us with 40n is less than or equal to 250. And now I'm going to divide each side by 40. And that leaves us with n is less than or equal to 6 and 25